the stool with books. It's actually physics. So they are just by the weight and the force from the table will keep it balanced. It's called the static equilibrium. There's not much going to happen until we do something about the books and the stool. So that's very different. That's what you learn in physics, right? But we are going to learn what's happening in chemistry. So if I have a glass of water and it will start to evaporate, and this evaporation takes place very high at the beginning, right? And then it's gonna, all the water is gonna be gone, right? And we know, so that's what happens. Now, what we can do, we can put a lid on it. So if we put a lid, there's no water vapor is going to go away. And also this kind of system is called the closed system. So in order to get an equilibrium, we need a closed system. And now what happens is the water vapor, water gas is going to condensate into liquid water. So there's two reactions happening actually. So endothermic evaporation happening and also exothermic condensation happening. Okay. Now this is called the dynamic equilibrium. So that means there is always some water molecules going up to the gas phase, some water molecules coming down to the liquid phase. So there's a dynamic happening. So that's why it's called the dynamic chemical equilibrium, right? So we have to look at them with the time needed to reach the equilibrium or the balance of the reactants and the products. Okay, and so we're gonna have a graph, so that way you can see easily the rate of evaporation versus rate of condensation. So we know we started with the very high rate of evaporation, and even for another reaction you can do the molarity on this case, right? But this one we can just say number of particles, right? And because we are not concerning the molarity for water, so evaporation started very high and slowed down and it's flattened off. So it's leveled off, right? There's a reason for it, because the space is running out. Now the condensation actually start from 0 and then it's going to increase and it's going to meet the same rate because we are measuring the rates against the time, right? So that means water liquid and water gas is at equilibrium. Okay, now we're going to go to a new equilibrium. This is hydrogen making meeting with nitrogen and making ammonia, right? And then it's an exothermic reaction, 92 kilojoules released, and so the delta S max means like a lot of particles. That's a driving force too. So let's say for this reaction, if you increase the reactants, and what happens is, based on the Chatellier principle, the system is going to push the reaction to the right to make more products to minimize the strain of more reactants, right? So it makes more ammonia, or equilibrium shift to the right. So that's what happens if you increase hydrogen or nitrogen. If you increase, if you take some of the ammonia, right, some of the products, take it away, so that means the system is losing products, so it's going to try to make products again, right? So always the Chatellier principle is very simply like Mother Nature fights back, right? So you do something to the system will try to undo or minimize the damage, right? And in this case we took the products, and then the system will try to make more products by shifting to the right or making more products. Let's say you increase the pressure of this system, because it's one vessel, it's a closed system. If you increase the pressure, the system is trying to lower the pressure by moving towards the less particles, less gas particles. So that means it should make more ammonia if we increase the pressure, because there is a lot of hydrogen particles and a lot of nitrogen particles.